Welcome friends. Today we will discuss our unit number 3, that is measurement techniques. In this chapter we will discuss two types of measurement techniques, that is impedance measurement techniques and voltage and current measurement techniques. As you know that impedance is a broad term which consists of resistance, inductance and capacitance. So as far as resistance is concerned, we briefly discuss what is meant by resistance measurement techniques and how to measure the low resistance and how to measure the medium resistance. In the low resistance measurement technique, we will discuss Volt-Ammeter method for the measurement of medium resistance and Wheatstone bridge method. And in the case of measurement of low resistance, we will discuss Kelvin's bridge method. So in the case of inductance and capacitance measurement techniques, we will discuss Maxwell bridge and sharing bridge. So in general, we will derive some expression or some equation and try to find out the circuit which can measure the resistance, inductance as well as the capacitance. The last but not the least, that is a frequency measurement technique, and which is very important techniques in a AC analysis or impedance measurement, that is the frequency measurements. And for this we will discuss how a Wien bridge circuit and how it is useful for the measurement of frequency. And as a important part, we will also discuss Q meter and complex impedance meter. Furthermore, we will also discuss digital LCR Q meter. And the second part in this unit, that is the voltage and current measurement techniques. So in this technique, we will discuss how to measure we will see how to measure the voltage as well as the current. And we will discuss a basic DC ammeter structure and basic DC voltmeter structure. Furthermore, we will derive the expression for the designing of DC ammeter and DC voltmeter. So this unit number 3 consists of some mathematical derivation, and based on this mathematical derivation we will design a circuit which can useful for the resistance, inductance, capacitance as well as a frequency measurement. Okay, so let's get started. So as we discuss, impedance is a complex term. So for example, if you measure a resistance, okay, so resistance is a concept that is generally deals with the DC analysis, so in which you are having a DC source and then you are measuring the resistance of your component, electrical component. But if you consider, or if you are having an AC signal, then you have to measure the impedance rather than your resistance. So impedance consists of your resistance as well as your complex component, that is the either inductance, capacitance or the frequency. So that's why we have a different bridges or different circuit in order to measure the different important concept in the electronics, that is a frequency, inductance as a capacitance. So let's start with our chapter with the impedance measurement. So measurement of impedance of any circuit deals with the measurement of a circuit resistance, inductance and capacitance. And the precision measurement of these components values have been done using some sort of bridges. There are two types of bridges, that is either a AC bridge or a DC bridge. The DC bridge are used for the measurement of resistance, while the AC bridge are used for the measurement of inductance, capacitance and frequency, admittance, so on and so forth. So as we discuss here, for the resistance measurement we use the DC bridge, and for the measurement of inductance, capacitance and frequency we will use the AC bridge. So as a input part, that is input source for a DC bridge is the DC source, and for the impedance measurement, that is for the complex quantity measurement, we will have a AC source. Okay, so as you know that DC means it has a fixed amplitude but no frequency, whereas in an AC bridge or AC source it has a varying amplitude and the frequency. So this is the AC bridge or AC source. So in the case of resistance measurement, so we have a three type of resistance. So in the resistance measurement we have a three type of resistance. The number one is the low resistance. The number two is the medium resistance. And number three, as usual, it is the high resistance. So for example, let us consider let's start with the low resistance. So the resistance of the order of 1 ohm, and they are considered as a low resistance. The resistance in the order of or from 1 ohm up to 100 kilo ohm are considered as a medium resistance, and the resistance above 100 kilo ohm are treated as a high resistance. So there are three type of resistance. One is the low resistance, medium resistance and high resistance. So the low resistance of the order of 1 ohm or less are called as a low resistance, or the resistance in the range of 1 ohm to 100 kilo ohm are called as a medium resistance, and the resistance greater than 100 kilo ohm are considered as a high resistance. So in our syllabus we have to discuss only two types of resistance, that is a low resistance measurement and the medium resistance measurements. So in the case of number that is medium resistance measurement, we have two types. We can measure this resistance by either Volt-Ammeter method, or we can measure the medium resistance by using a Wheatstone bridge. So medium resistance can be measured by either a Volt-Ammeter method or a Wheatstone bridge method. There are many two types, again another two types, that is ohmmeter method as well as a substitution method, but in our syllabus we only have two types of method in order to measure the medium resistance, that is the Volt-Ammeter method and Wheatstone bridge method. Therefore we will discuss only these two types of method, that is Volt-Ammeter method and Wheatstone bridge type method. So let's get started with the first method, that is the Volt-Ammeter method. So this is the Volt-Ammeter method. This is the Volt-Ammeter method to measure the medium resistance. So this Volt-Ammeter method is based on the measuring the voltage across the unknown resistance and current passing through the unknown resistance. So this method is based on the measuring voltage across unknown resistance and current passing through the unknown resistance. So mathematically we can write like this. So basic Ohm's law, that is unknown resistance Rx, can be obtained if you know the voltage across your resistance and current passing through your resistance. So this is a basic mathematical expression in order to measure the medium resistance or unknown resistance, medium unknown resistance using the Volt-Ammeter method. So this is the first circuit arrangement for the Volt-Ammeter method. So there are two types of circuit arrangement for the measurement of unknown medium resistance. So this is the one. The second one we will discuss shortly. So you can see the simple circuit which consists of simple voltmeter, an ammeter and unknown resistance Rx. So basically it is a DC method because we are applying only a constant voltage source which has an amplitude phi. So if we apply voltage across this unknown resistance, so this voltmeter measure the voltage across the unknown resistance Rx, this ammeter measure the current passing through your unknown resistance Rx. So that's why we have denoted like this. So this is symbol I, which represent the current flowing through this circuit. So this I also flows through this voltmeter also, and this I ammeter. So this I now we call as a, because it is flowing through Rx, we call as a Ix. So based on we can have two types of arrangement. So if you consider this figure number A, that is our first arrangement, that is ammeter. So in this circuit, the ammeter measure the true value of the current flowing through the unknown resistance. So what I said, so this ammeter measure the true value of current passing through the unknown resistance, and the voltmeter is not able to measure the true voltage across the unknown resistance Rx. So why I said this? Because if you consider this unknown resistance, so ammeter is close to your Rx, whereas voltmeter it is not close to your Rx, because this ammeter also gives some sort of resistance to this current I, and because this is not close to this unknown resistance Rx, or simply this ammeter is close to Rx, this ammeter measures the true current flowing through this Rx, whereas your voltmeter is not able to measure the true voltage across Rx, because this ammeter also some sort of resistance which also adds to this Rx. So that's why it is not able to measure the true voltage across the Rx, and this we will be we have to find out mathematically. So the voltmeter, as you know, that indicates the sum of voltage across ammeter and the unknown resistance. So what I said, the voltmeter indicates the sum of voltage across your ammeter as well as the unknown resistance, because this ammeter also very small resistance, that we have to consider, otherwise we cannot get the correct answer. So because this ammeter has some sort of resistance and this also adds in the Rx, so that's why the voltage across your voltmeter indicates the sum of voltage across your ammeter as well as the unknown resistance. So V can be written as a V is equal to Vrx plus Va. If you apply a simple Ohm's law here, then this expression can be written as a Ix into Rx. So because phi is nothing but it is a phi is equal to IR plus, so Va, so this is voltage across your ammeter, so current that is flowing through ammeter is Ix into its resistance Ra. So this Rx can be Vrx can be written as a current flowing through this, that is Ix into its resistance Rx, and voltage across this ammeter can be written as this current, that is Ix into its resistance simple Ra. Then we can write like this Ix, because we can get this term outside, that is Rx plus Ra, or simply we can write like this: V divided by, if you take this Ix here, V divided by Ix is equal to what you get, Rx plus Ra, Rx plus Ra. So now this term, that is Rx plus Ra, is called as a Rx plus Ra is called as a Rm. Or it is simply we can write like this: Rx plus Ra is equal to Rm. That is the measured resistance. Measured resistance. This Rx plus Ra is nothing but the Rm, which is nothing but the measured resistance, because we are measuring the, although we are measuring the Rx, but this ammeter gives some sort of resistance. Okay, and because of this resistance Rx plus this resistance of ammeter Ra is called as a measured resistance Rm. So Rm is nothing but the, what we call it is a Rx plus Ra. Or if you have to find out the Rx, then you can write simply like this: Rx is equal to Rm minus Ra. You can simply write like this: Rx is equal to Rm minus Ra. So this is equation number 1. So this equation gives some important results. So this equation gives some important results. So the unknown resistance or unknown, so if you can find, you can find the value of Rx, that is unknown resistance, is the same as the measured resistance if and only if. So Rx is equal to measured resistance, because we have to measure the resistance and we have Rx. So the Rx unknown resistance is equal to Rm measured, that is Rm, that is measured resistance. It is equal to, or it is same as the measured value Rm if and only if the ammeter resistance Ra is the 0. If you keep this Ra is 0, then your unknown resistance will be equal to your measured resistance, and this is the ideal way to measure the Rx. But in a practical way, we cannot have the ammeter which has a resistance 0. So that's why, so practically the measured value, that is your measured value, is always greater than your true value, that is your Rx. So this is one of the limitation of this circuit or a Volt-Ammeter method. That is our first arrangement to measure the unknown medium resistance. So with the help of this equation, that is Rx is equal to Rm minus Ra, you can calculate the unknown resistance, or by simply using this expression you can find out the unknown resistance. But one of the limitation of this network is that the measured value is equal to your true value if and only if the Ra will be 0. But in a practical way, it is not possible to keep the resistance of ammeter 0, because ammeter provides some sort of resistance to the circuits. So that's why this circuit provide the measured value is always greater than your true value. It is one of the limitation of this circuit.